Hi everyone, this is Andy with Voss Aerospace, and today I'm going to show you how to set up a brand new MiraSport VTOL. So as you can see, I'm using Libre Pilot, and this is Libre Pilot Ground Control Station 15.09, and I'm sitting on the welcome screen here. We're going to be setting up a new MiraSport with a CC3D flight controller and a Spectrum DX6 radio transmitter. There are a number of options, but this is basically the package that we've been setting up with our ready-to-fly models. So the first thing we need to do is connect the board to the computer and make sure that everything is communicating properly. So I already have the USB plug attached to the computer and then disconnected the board. So I'm just going to go ahead and click connect. If you haven't plugged in the board yet, just go ahead and plug it in and it will connect automatically. So you can see here that the board is now communicating properly with the laptop. So the first step in the process is to go through the vehicle setup wizard. This is pretty typical for any new multi-rotor, but there are a couple of steps that are unique to the MiraSport. First things first, make sure that you remove all of the props before you go through this setup process. It's just safer that way. The first step here, we need to upgrade the firmware to make sure that the ground control station and the firmware that's on the board are the same version. That makes sure that all of the behaviors are well defined in between each of those, and that it doesn't do anything odd. So we'll click Upgrade and erase all settings. This takes a minute and the board will disconnect, as you just heard. Firmware is being uploaded to the board. The board will reboot. Sometimes this takes a minute. And the board is now rebooted and is reconnecting. So now you see that I can click the next button and everything should work fine. So we'll click next. You can see that Libre Pilot recognizes the controller as a copter control board and a CC3D. And again, we click next. The board will reboot again. And it will reestablish communication with the computer. Now, the first step in the process is to basically tell the board what kind of communication you're going to be using with the receiver. So, for our setup, we're going to use PWM. Some of you are probably wondering why. For the VTOL specific setup, we need to simultaneously use the channels, or rather the signals coming out of the receiver to control things on the flight control board and the aileron and elevator servos simultaneously. So there are configurations that we can do that will use basically PPM or S-Bus or Spectrum Satellite in the future. But at this point, the most universal setup that we've come up with is just using simple, using simple PWM. So click next again. And this is a multi-rotor setup, at least as far as the flight controller is concerned. So select multi-rotor and again click next. And in Libre Pilot, there is no configuration for a quadcopter with a V-tail, which is effectively what the MiraSport is. So we're going to choose Quadcopter X. The only difference is the direction of the motor rotations. And I'll explain that a little bit more when we get there. The speed controllers that we supply with the MiraSport are rapid high-speed ESCs, so make sure that rapid ESC is connected. We can take a quick look at the wiring diagram. This is what everything should look like. So white wire with the power cables attached, that's the red and the black wire here, are attached to the output for throttle. Blue is attached to roll. The first yellow is attached to pitch. The green wire is attached to the yaw output, or the rudder output. And the second yellow wire, it's shown in orange here, but the CC3Ds actually have a second yellow wire. That second yellow wire is your flight mode, and for our purposes we're attaching that to the auxiliary output channel of a Spectrum AR610 receiver. We'll click Save. And we'll just save this as Setup, Wiring. You can skip this step if you'd like. These images are always in there in the setup, but sometimes it's handy to not have to plug in the board to go back and look at the wiring diagram. And we'll close that window out. We click Next. This part's important. Make sure that your copter is sitting on a very flat and level surface. This calibrates all the sensors that are on board. Click Calculate. And once it says it's done, you can go ahead and click Next, and the values of the gyro and accelerometer offsets are saved on the board. Next, we have to calibrate the ESCs. So make sure that you really do have all of the propellers off the motors, because like I said, it's just safer that way. And this is showing you need to have the battery handy but disconnected. When you hit Start, it's going to ask you to connect the battery. I'll do that right now. So in the background you can hear the ESCs powering up and calibrating. Hit Stop, and you'll hear another set of tones from the ESCs. And that last chime with these speed controllers means that everything is all set and calibrated. Then you can go ahead and unplug the battery ahead of the next step. Once you've done that, go ahead and click Next. Again, very important, make sure all the propellers are removed before proceeding with this next step. This next step is motor calibration. So now you need to plug the battery back in, and you can hear the ESCs have powered up. Now we're setting the 0 points, or the neutral points rather, for each of the motors. So in the cartoon here, it's showing this motor spinning clockwise. On the actual MiraSport, because it's a V-tail, you need to have this motor spinning counterclockwise. And in general, all the directions of the actual motors need to be opposite this specific cartoon. The motor IDs are in the same positions on the aircraft, but the direction of rotation is reversed for all of the motors. And again, that's important because it's a V-tail aircraft. So we'll click Start, begin to slide this up. You might be able to hear this in the background, but motor 1 is now spinning. I'm checking the orientation, and it's spinning in the correct direction, so we can hit Stop and move on to the next motors. So again, same process. Click Start, raise the slider until you hear it start to spin, verify that it's rotating the correct direction, and hit Stop. And again for motor 3, start, move the slider, verify rotation direction, and click Stop. Next motor, click start, raise the slider, verify the direction of rotation, and then click stop. Now, something's odd is happening here, and that's the motor that I've just set up is continuing to spin even though I've hit stop. And I'll show you how to deal with that if it happens in the next set of, well, basically later in this video. And go ahead and click next. So we've found that the closest tuning to what the MiraSport needs is actually the blackout 330 settings. Now, these gain settings, they're a little bit high for us in just quadcopter mode, but in full VTOL mode, they actually work reasonably well. So they represent a pretty good compromise, and we'll modify them later in the setup too. So use those as a starting point, and go ahead and click next. The last step here is to save, and this will save all of the configurations that we've just input. You'll hear the board reboot, and I still have the battery plugged in because we need it for the next step. So now I'm going to grab the transmitter. I'm going to turn the transmitter on, and with the battery plugged in for the next step, we'll go ahead and enter the transmitter setup wizard. You can see that the arming setting is going to be set to always disarmed. Again, that's for safety, and make sure that you have the propellers still off of the aircraft. Hit OK. And next we'll go in and go through the setup. So this is a normal acro style transmitter. And we're going to choose mode 2 because rudder and throttle are on the left-hand stick. Go ahead and click next. It's asking you now to move the throttle channel. So if I move the throttle channel, you'll see the indicator stop moving. Now I'll do roll. Now I do pitch. Now yaw. And then I'll start moving the flight mode switch. Now because we're only running on a 6-channel transmitter, we can go ahead and skip these accessories. If you want to program more accessories, you can do that, but we're not going to cover that in this video. So we'll just click next, next, and next. So now it's asking you to center all of the controls. And then the cartoon shows them moving like crazy, but really it makes sense to just go to all the corners and extremes of each channel's travel. Again, this just calibrates the range of each channel. And click next once you've done that. You probably noticed that if I try to roll left, the indicator on the screen moves to the right, and vice versa. So now we have to go in and select which channels we'd like to reverse to make sure that what we move on the transmitter matches what we're actually doing on the real transmitter, or rather that the transmitter matches what's on the screen. So in this case we need to reverse roll, pitch, and yaw. So now if I roll right, the indicator moves to the right. If I pitch up, it's like I'm giving up elevator, down elevator, so on and so forth. And the same with rudder. Yaw right, yaw left, high throttle, low throttle. And everything is moving the way it should be. So again, what I'm doing with the actual transmitter is reflected in the graphic on the screen. And we're all set with setting up the transmitter. And we're going to change the arming setting to yaw right. This is the standard for arming most multi-rotors, which means that the disarm command is yaw left. If we click save, and then if we hold yaw right,
armed,
you can hear that it says that the board is now armed. And you can hear, if I play with the throttle stick, you can hear the motors spinning in the background. So I'll go ahead, turn that down, and I'll disarm the board. Click Save again for good measure, and then we'll move on to the vehicle setup. So for us, because we have a V-tail, we have to go into the mixer and we have to change a few of the yaw settings. So roll and pitch commands are the same, but yaw commands, because we have a V-tail, have to be reversed. That's pretty simple to change. You see, for the conventional multicopter, motor 1 on channel 1, you have a negative input. Motor 2 on channel 2, you have a positive input. Motor 3 on channel 3, you have a negative input, and so on for channel 4. So what we need to do is we need to name our new custom model. So we're going to call it MiraSport Setup. Hit Enter. Hit Save. Sometimes you have to do this a few times before it'll let you into these boxes. Yeah. See, I need to do that once more. Now it'll let me change it. And all you need to do is just change the sign on each of these yaw commands. So -64 becomes just a +64. Hit Enter. +64 becomes -64. Negative again becomes positive, and positive again becomes negative. And we'll save that configuration. This is important because the motors, again, they're spinning the opposite directions from a conventional quadcopter, and the tail rotors have a little bit of cant, so they're able to essentially better yaw the wing in hovering flight when you're flying as a full VTOL. The next thing we're going to do is we're going to look at the RC inputs. So under here, we're going to look at the flight mode switch settings, and we're going to set these up in the following way. So we prefer to set it up as the first two modes are stabilized on bank 1, and the third mode is on bank 3. One thing to watch out for is that you don't want to use axis lock when you're planning on flying as a full VTOL. Axis lock will cause some odd flight characteristics when you transition from forward flight back into a hover. So we're going to select rate for all of these modes. So for stabilized 1, we're going to use attitude for pitch and rate for yaw. We'll use attitude, and rate. Again, this is going to be the intermediate or the acceleration setting as you're speeding up or slowing down in between hovering flight and forward flight, or vice versa. And stabilized mode 3 is going to be rate, and rate. In each of these modes, thrust should be selected as manual. And we'll go ahead and save that setup. Now we're going to look at the RC inputs. So we have 3 flight modes. So you see the, actually up here, we'll start with the throttle stick. As I raise the throttle, this channel indicator moves as well. Roll. As I move the stick, the indicator moves. And same with pitch. And again, the same with yaw. And then we're going to check the flight modes. So mode 1, this is going to be stabilized hover mode. Mode 2, this is going to end up as the acceleration mode as you move from hover into forward flight. And then this is going to be your full forward flight mode. So again, back to 2, and again back to 1. You want to make sure that the indicator falls well within each of these bounding boxes, just to make sure that your flight mode is going to be what you actually select. And we'll hit save again there. Now, remember from earlier in the tutorial, we had a little bit of an issue with motor 4 continuing to spin even when the board was disarmed and the throttle was at its idle position or zero position. And that's because with these speed controllers, the control range in their own firmware is set relatively wide. So what we can do is we can actually reduce the minimum throttle setting that the board is sending to the ESCs. So we're going to just step these down basically by 2 clicks. You can go more if you need to, but we prefer to do each of these at the same time. And once you've reduced those settings, we'll hit save. It's just good practice to make sure that these are all the same. It keeps your life nice and simple. Then we're going to look at the stabilization. For bank 1, these are the settings that we're going to be using in hover mode and in accelerate mode. So when I fly, I prefer to increase these just a bit. I fly with a bit of expo, and I like my yaw especially to be a little bit snappy. So generally I increase these from the default settings that we loaded earlier. And I also increase expo from the default 12. I increase these to 20. And I generally leave yaw at -5 because I like to have yaw really pretty snappy. So we'll go ahead and we'll save those specific settings. There's a free bank, bank 2, that you can utilize if you'd like, but for us right now for this tutorial we're going to set it up just so you have basic VTOL functionality, and that's required in bank 3. So the key is that when you do the transition from hover to forward flight, in hover your rotors are controlling the attitude of the aircraft. In the accelerate mode, your servos, so your ailerons and elevator, are helping to manage the attitude of the aircraft in addition to the rotors. And once you go into full forward flight, you only need aerodynamic surface control. You don't need to have any rotor control. So the unique thing about LibrePilot is it allows you to set all of these rates and all of the PID gains all the way to 0. So effectively nothing will happen with the rotors when you're giving directional input commands when you're in full forward flight. You'll only be utilizing the aerodynamic surfaces, so the ailerons and the elevator. And we'll click save. Now we're going to just check and make sure that the inputs are set up the way they're supposed to. So we're going to select always armed, again making sure that the prop is off. We'll hit save. You'll hear the armed prompt, and when I throttle up you'll hear the motors spool up, and you'll hear, as I move the control sticks, you'll hear differential thrust being applied. As I change to my intermediate flight mode, you still have rotor control. And then when I change into full forward flight mode, I'm still moving the stick, but you don't hear any more flight commands. And now I'll transition the controller back into hover mode, and again you hear that the rotors are controlling the attitude of the aircraft. Now we can go back to 0 throttle, change the arm setting back to yaw right, and click save. There. You want to make sure that you see that green check mark show up, even if it's just for a brief second. Just to make sure that everything is working correctly, we're going to go into flight data, and we're going to make sure that the accelerometers are recording the things that they're supposed to. So if I lift the nose of the airframe, you see basically the graphic in the lower corner lift up. If I lower the nose, see it actually pitch down, and roll, although it's facing me right now, is in the correct sense. And yaw as well. So you just want to make sure that everything is moving the way on the screen that you're moving the actual aircraft in real life. And at this point, it looks like we're all set, and we can go ahead and do a hover test. We're going to also be adding a hover test, a first hover test video to this video series as well. So thanks a lot. Hope you watch the next few videos.